platforms. We know them from the oil and gas industry and from solar farms. But what about floating wind farms? They exist and they probably have a future. To talk about that, here we have Tim Isles and Ben Andrew from Acteon. Yeah, good morning. Tim Isles, you're the Vice President of Acteon. You provide industry-leading products and services for the renewable, nearshore construction and the oil and gas sectors across all phases of the life cycle. What is the coolest thing you're working on right now?
So right now, I'm working on the operations and maintenance plans for future floating wind farms, both in the UK and in the US, and then in probably places like Japan and Taiwan. So
yeah, they're floating. You can bring them everywhere. So
that's right. Yep.
They're everywhere. Ben Andrew, you're the director of 2H. You deliver leading-edge advanced system engineering for all types of offshore structures in both oil and gas and the renewable sectors. What is your coolest project you're working on right now?
The coolest project right now, I would say, is definitely a large-scale drill that we're designing, or drilling system for fixed wind. But we're also looking at how that same technology can be transferred to floating wind for efficient installation of the anchor systems.
Ah, okay. So I thought floating, you don't have to drill, but else they float away. Yeah. We're going to talk about floating wind farms. I always thought solar is floating, perhaps, but those wind farms, they're so big, you need to put them on the ground, because else they just float away. How old-fashioned is my thinking?
Maybe a little bit old, but yeah, so for a floating wind farm, you've got a traditional turbine and a tower that you would see for fixed wind, and then that's attached to a floating hull, similar that you would have in oil and gas, and that hull, steel normally hull, is attached to the seabed using mooring systems that, again, you would typically see in oil and gas. Down onto the seabed, and that mooring's held into the seabed through anchors, through drilled and driven piles that Ben was discussing. So we've got that floating unit, moves with the waves, and then the turbine on the top. So that's what they look like.
Why would I choose for floating instead of fixed?
So it's really driven by a water depth decision. So in the shallower conditions, you can...
Yeah, your video is going to play in the background, yeah.
So yeah, in the shallow water condition, you can work with fixed, but as you move into deeper water, you need to move towards a floating condition in order to manage the cost of that. The problem is when you move to that floating infrastructure, you move from a pretty static and fixed regime to a much more dynamic and hence a much more complicated system. And to make that work, you've really got to think about how that dynamic system is going to work, which is something we're very used to doing in oil and gas, but it's quite different in the wind market where people are used to fixed, rigid, static structures. So it's that dynamic aspect.
What is basically the amount of meters where floating is more cost efficient than fixed?
So once you get beyond about 60 to 80 meters, fixed starts to struggle. The problem is that there's then actually a region up to about 150 meters where floating is still quite difficult, and it really starts to work beyond about 150 meters. But the trouble is the industry wants to work its way logically into deeper and deeper waters. So some of the challenges are actually bigger in that intermediate region between 70, 80, and 100 meters.
If I look at the maps of where future wind parks are planned, they're going to get further and further away from the shore, higher depth. So is floating going to be equally important or maybe more important than fixed in the future?
Depends where you are in the world. Certain countries don't have that shallow, near-shore acreage to put fixed wind. So in those countries, places like Japan, Taiwan, some of the US, floating wind will play a really key part in enabling renewable energy sources in those regions. So it's quite geographically diverse where floating wind is going to play a part, but probably generally, yes, it will do. There's a lot of challenges in developing floating wind, especially with the economics. So when we see these big commercial floating wind farms become more common, we'll be a few years away yet, but there's a number of pilot wind farms, small demonstrators already installed.
Okay, well, let's talk a little about those challenges and also what we can learn from the oil and gas industry that has been dealing with these challenges for the last 50 years, how we can use those learnings to the future. What are some of the biggest challenges we're walking into?
So I think if we start with the sort of design side of it, the biggest challenge is, as I say, with floating wind, is that it's such a dynamic and complex system. The turbine needs to be stable, the platform needs to operate properly, the excursions need to be limited so that the cables work, the mooring system needs to function without overloading the anchors. So there's a lot of complex engineering challenges that interplay with one another. And one of the things we've learned in the oil and gas industry over many, many decades is that you need to consider that as a system. If you try and package that up and design individual components in isolation, you end up with a very inefficient system or one that doesn't work at all. So you need to look at it much more as a system rather than individual packages, and you need to understand it holistically. And I think the same translates through to the operational side as well.
Yeah.
So for operations for a floating wind farm, you've got a number of activities that you're going to be doing every year on a floating wind farm. You're going to be doing inspection work, maybe some light maintenance, and I'm mainly talking here about the subsea bits, the wet bits of that infrastructure. You're going to have monitoring systems, but you've got a lot to inspect. You've got all these moorings, cables, the hull, the anchors.
To switch to something wrong with the microphone. Yeah.
That's not on it. There we are. That's on as well. So yeah, you've got lots of components to look at. You've got lots of different techniques to use. So the amount of work to be done offshore could be quite extreme and cost prohibitive. So one of the things we've picked up from oil and gas and that we've been doing with oil and gas operators is looking with a risk-based approach for O&M. So you start early on in the design phase. You look at all the different failure modes that can happen with a system. And for each of those failure modes, you assess what's the best type of technique to give you the information whether that failure is happening. So you might have to just inspect it visually. Some places on these platforms you can't inspect. So if it's critical, do you need to put monitoring on there, permanent monitoring? Or do you need to have a spares philosophy? So you know, for example, mooring systems will fail at some point during the life, or there will be some failures. There's going to be a lot of mooring lines. So you need to be thinking about having a spares philosophy for the mooring system. So all these things we've been used to doing in oil and gas, and we need to translate that now into floating wind. And one of the other tools that we've developed in oil and gas and used quite successfully is the digital twin. And what we're talking about here is a digital response twin. So it's not a 3D model that you might be used to seeing. This is an analytical model that's running in the cloud and has been developed using machine learning techniques and others. And it gives you an extra set of virtual sensors. So it provides you data around the platform. For example, key interfaces on the moorings, on the cables, maybe key welds on the structure on that floating platform. And it provides you extra data that you wouldn't get through the standard inspections and monitoring. And that tool can then be used to help operations, so you know whether these platforms are performing properly. They can help validate the design. Was the design overly conservative or under conservative? So when you do the next wind farm, you can make improvements and cost savings, hopefully. And really importantly, you can look at life extension. So through these tools like digital twin, monitoring, inspection, what we really want to do is collect data about the asset and how it's been performing and look to take the design life for a floating wind farm. Typically, maybe it's 30 years to start with. Can we add another 5, 10, 20 years onto that? And you can only do that with the data you've been collecting during the operation of these assets. And again, this is something we're used to doing in oil and gas. And you'll be familiar with a lot of older platforms, subsea infrastructure that's still operating well beyond its original design life, very safely, but that's come through assessment and data collection. Yeah. So these are the tools we can use.
Ben, if there's a tender for a very deep sea wind farm, and I'm not a big oil and gas company, should I even apply, or are the traditional oil and gas companies going to outcompete me by large because they know how to do this?
I think there's a piece of that they are more familiar with that deep water, highly dynamic applications. But I mean, what we're not arguing is that the offshore wind farm is a carbon copy of an offshore oil and gas farm. There's plenty of things that are different, plenty of things that the floating wind development can learn from the fixed wind development as well. The important point is to realize that the fixed wind development and the floating wind development are very different in many ways. And therefore, there are things to learn and transfer from the oil and gas. It's not like moving to floating just becomes an oil and gas market. It's the sort of the learnings from both worlds are going to be required to make them a success.
If I want to get into this, should I be warned by you or should I be excited by you?
Hopefully a bit of both. I think we've worked within Acteon and our companies on both oil and gas and wind projects. They're exciting projects to work on. They're cutting edge. They're giving us renewable energy. So we shouldn't be afraid to tackle these challenges. We just need to do it thoughtfully. We need to do it holistically, like Ben's talked about, and then we will have success. We've had great success with floating oil and gas platforms. We've had great success in fixed wind. So the two will come together, but going at it with a very simplistic and not with your eyes open is what we want to avoid.
Yeah, I'd agree. It's something to be excited about, but it's something to be aware that it's different. So be excited about it, but don't forget all the learnings from older industries and where they can play in.
Yeah. We don't want to reinvent the wheel. A lot of these challenges we have come across before, so we just want to pick them up. But yeah, as young engineers out there, especially, it's a really interesting area. Lots of some challenges, engineering, analytical challenges, so it should be exciting to work in.
It's also going to mean that the more we research and learn, the depth to where floating become more economically viable than fixed is going to go up, and maybe in the future we also will see floating near shore?
I think it will still remain the case that in shallow waters, fixed will be king, because there are challenges with floating and there's not the reason to go to it. But it's the regions of the world which cannot develop the fixed wind at all that I think the most excitement is about, whether it be some parts of the Mediterranean, some parts of Western America, for example, where you get very deep very quickly. And that's really where the floating, I think, is most exciting.
This opens up lots of new areas for possible wind farms.
Yes, that's right, yeah.
Well, good luck exploring this new part of the world, and let's see how deep we can go with wind farms.
Great. Thank you very much.
Thanks so much.
Thank you.
Cheers.
And I see we have about 1 or 2 minutes left. Are there questions or comments from the audience? Because we have people with a microphone. Yeah, there's someone over there. Can you get a microphone over there? Yeah, go run.
Furthest possible.
The gentleman over there, yeah.
Hi, and thank you for the nice...
Who are you?
Oh, my name is Ralph Donners. I work for Skyborn Renewables. I was wondering, can you elaborate a bit on what makes the shallow water so extra challenging?
I'm not sure my microphone's on,
Microphone?
but... Yeah, does that work? Does that work? That one works. I think one of the big challenges in the shallow water is the power cables. You have very little vertical space between the floater and the seabed, and yet you've got quite large excursions of the floater. So coming up with a power cable configuration that works under those constraints is challenging. And I mean, these highly dynamic electrical cables are very new and going to be challenging from a fatigue perspective, the electrical perspective. That's the biggest one for me, although there are other challenges in the moorings as well.
Yep.
Anything to add, Tim?
We see another question over there.
Philip Woodcock, Windward Maritime. Where do you see the next big development going, location going to be for floating offshore wind? When's going to be the next big wind farm?
Say Mediterranean.
Sorry. Well, there's some planned for Scotland in the UK. There's some small pilot wind farms, smaller ones going into the south in the UK, Japan.
I mentioned the Mediterranean as well. I think some of the Mediterranean Sea is well suited.
A number of leases were awarded in the US. How long they take to develop? They're in quite deep water, so there'll be some challenges and cost constraints on those, I think, to get those over the line. But yeah, those are the regions we're seeing them.
How deep can we go?
I don't know if there is a real limit.
There's no practical limit. I mean, we do deep water oil and gas in 3,000 plus meters. There's no reason you can't do floating there. Whether it's economical in the near future, I doubt. But why not?
Well, we need a lot of energy in the coming years, so maybe in the middle of the ocean and then make hydrogen from it and ship it by balloon.
Absolutely.
We might do that, yeah. Are there more questions from the audience? I see none. Oh, yeah, I see, there's one. Oh, yeah. Yeah, tomorrow I should wear sneakers if I were you. Yeah.
Hi, Michael Hook, Shuttle Marine Technologies. I'd be interested to know, where do you see the transition in terms of depth of water from what is now the go-to semi-sub to going more towards semi-taut and ultimately TLPs? Where's the sort of that transition piece? You
have to explain a little bit of the abbreviations you just used.
So TLP, tendon leg platforms, semi-sub, semi-submersibles, which are like your principal powers. I guess it's where's that tipping point between the two do you see?
So it may be a controversial thing. It's not so obvious to me that the semi-submersible has a depth at which it's going to stop being practical, I don't think. The TLP solution's an interesting one. Doing TLPs on the scale of an offshore wind farm, I'm yet to be convinced by, because high axial loads on the anchors are a big challenge to deal with. Motion characteristics are great for the turbine, but excursions are high, challenging for the cables. So it's not obvious to me that there's a water depth at which you need to discard the semi-submersible option and move to something else. I think it's probably more about the metocean conditions that you're handling. So certain locations will be more suitable to a spa. That doesn't work in shallow water, but it does start to become practical when you're deep enough.
Are we going to see a variety of methods in the future, or is it all going to come to one?
I think it's going to be similar to oil and gas, where you have different types of platforms for different locations and different, as you said, meto conditions. So you'll see a variety. I don't think we'll end up with one platform technology globally. I suspect we'll have semis, we'll have TLPs, spars, and other more novel or hybrid solutions. And I think that there'll be the right tool for the right job. And that's what we've seen in oil and gas. I don't see why it's going to be much different. And the other thing that comes into play is local content, local supply chain. And again, we see that in oil and gas sometimes, where you choose a technology that may in one place not make sense, but it makes sense locally because you can manufacture locally, you've got a local supply chain, support economic development in that country or that region. So not one solution fits all.
And I'd add in the ground conditions, the geotechnical as well. That comes to my point that you've got to look at it as a system. Because if the ground conditions don't support a high tensile anchor, TLPs aren't going to work regardless of whether they're well suited in the metocean conditions.
Okay, we really have to wrap up. Is there a last question? Seeing none, then we're going to thank you so much and good luck with having our seas filled with floating devices. Thank you so much.
Thank you very much.
Big round of applause for Tim and Ben.